Today we will discuss about how to solve bag price problem using EDA technique. EDA means estimation of distribution algorithm. So we already know that this EDA algorithm in R, it performs minimization task and it will accept 4 arguments: EDA, instance, F evaluation function, lower and upper vectors. So let us execute one by one. First of all, load the library. So if this library is not present, better to install it. So load the library and then define the profit function. The implementation of this profit function is already discussed in the previous classes. So we already know the bag price problem is all about finding the optimum values for all the selling price. So in the question, 5 bags are there, so dimensionality is 5. So let us implement the objective function. So we executed, we set the dimensionality as 5 bags are there. Let us suppose we want to execute 1000 iterations. Let us 1000, and the population size, number of solutions in each population, let us take 5, and then this is for probability. Then you have to set this control list parameters. We already discussed it. You have to create a EDA instance. So it is like control parameters where you will pass the population size, maximum number of iterations, all these things. You execute it. To store the temporary results, you execute this statement, and then finally call the EDA algorithm with the help of EDA instance, evaluation function, and then lower vector, higher vector. Lower vector is 111 and upper vector is 1000. Okay, so you need to find the optimum values between 1 and 1000. So bag price problem is all about that only. So let us execute the show function. You can see what is the best value you got, and finally let us execute the best solution. What is the optimal solution? Yes, we got the final values for selling price for 5 bags is the one, and its corresponding profit value is this one. So we already discussed that EDA run function, it generates the E class. With the help of E class, we can access the different elements like optimum solution, best solution, and its evaluated value. So that's what we have done. So if you want to analyze the population for each variable, you can execute this code. So you can see 1000 iterations. See how the code executes and standardize. This is for first variable. You can run this code for 5 variables because the dimensionality is 5. So with this statement, you can find out the best optimum solution. Okay, students, you need to remember this function and what are the arguments you have to pass. Okay, this is about EDA algorithm, estimation of distribution algorithms. So I want to load this library. Thank you, students.